Hi everyone, welcome back to Civil Engineering with Amir. Today we're going to solve a question on the topic of strain deformation equations that we have selected from Craig's Mechanics of Materials or Solid Mechanics. Before we start solving the question, I want to ask you guys to support us by subscribing to the channel if you haven't already. Okay, let's read the question together. So here we have a thin wire which is deformed in the x direction. So the original length was L, and after deformation its length is going to be L plus this delta L. And now the question wants us to prove that delta L is actually the integral of the extensional strain of the wire from 0 to L. And also in the second part, we have to determine the elongation of the wire, which is subjected to a change in the temperature. Okay, let's assume this is our original wire. And before we apply the deformation, we put some signs at the beginning and the end of this wire and somewhere in the middle. So let's say for this point, x is 0. For this point, x is L. And for the middle point, we're going to assume that it's located at the distance x from the beginning. So this is going to be x. This is before deformation. And after deformation, so I'm going to put it right over here. It's going to look like this. So we're going to keep this point x0 at its location. So this is x equal to 0. This elongation, we can call it delta L. So this will be L plus delta L. And for this point, we just call it Ux. So Ux is actually the displacement of a point which is located at a distance x from the beginning of our wire. So for this point, Ux equal to 0 is actually 0 because this point didn't move at all. For this point at the end, Ux equal to L is L plus delta L minus L. So it's equal to delta L. And for this point at a distance of x from the beginning, Ux equal to x, we're just going to call it Ux. So we know our Ux is a value between 0 and delta L. And now let's assume at the beginning of our deformation test, we had selected another point. So this is at the distance x. This is at the distance x plus delta x. And the length of this piece is going to be delta x. After deformation, the length of our element will increase. And we're going to call it delta x star. So this was our point x, which moved to this point. So this is going to be Ux, and similarly for this point, it moved to here. So this is going to be Ux plus delta x. Now our delta x star will be this Ux plus delta x movement of this point minus movement of this point Ux plus this original delta x. And we know our strain is the limit of our delta x star minus our delta x divided by delta x, when delta x approaches to 0. So this will be limit of ux plus delta x minus ux divided by delta x when delta x approaches 0. So we can call this delta u, and this will be limit of delta u over delta x when delta x approaches 0, or du over dx. So our epsilon x will be du over dx. So we can write du is epsilon x dx, and if we take an integral from both sides of this equation, we can write integral of du is equal to the integral of epsilon x dx. And we know from here that our u changes from 0 to delta L, 0 to delta L. And we know our x changes from 0 to L. So this is 0, this is L. So we have delta L minus 0 is equal to our integral of 0 to L epsilon x dx. So delta L will be the integral of 0 to L epsilon x dx. And this is exactly what the question wants us to prove. So this is the answer of part A of the question. And in part B, the wire is subjected to a change in the temperature, and the equation for the change in the temperature is given to us. So we have delta T is equal to 10 multiplied by x in the power of 2, and we have alpha is equal to 20 multiplied by 10 in the power of negative 6. And we know epsilon x is alpha delta T. So epsilon x at each point x will be equal to 200 multiplied by 10 in the power of negative 6 over meter x in the power of 2. And now if we put this epsilon x in our delta L equation, we can write delta L is the integral of 0 to 2, which is the original length of our wire, 210 in the power of negative 6 x in the power of 2 dx, which is equal to 210 in the power of negative 6, 2 in the power of 3 divided by 3, which is approximately equal to 533.310 in the power of negative 6 meters. Okay, that's it. Thanks for watching this video. If you liked it, don't forget to give it a thumbs up. If you have any comments, suggestions, or feedback, feel free to write for us in the comment section. And finally, if you haven't already subscribed to our channel yet, please support us by hitting the subscribe button. Thanks again for joining me today. See you in the next videos.